In this video, we will derive the equation for current through inductor in a source-free RL circuit. Let us consider a circuit where there is one inductor and a resistor and there is no source. Now if there is no source, how the current will flow, that is the major question. So we consider that at t equals to 0 there is no source, but at t less than 0 there was some source, and due to that there is a current through inductor in the circuit. Okay, so the circuit will be at t equals to 0 when there is no source. The circuit will be driven by the current, initial value of current in the circuit at t equals to 0. This is inductor and this is resistor R. For simplicity in the derivation, we will take I of t, current, as I. Okay, just representing I of t with I. Now, to find the current in the RL circuit, we apply KVL. To apply the KVL, we should have the polarity of voltages across the components. So, in this circuit, yes, current is flowing in this direction. So, from the point when it enters, that will be the positive, and from the point from where it is leaving, that will be negative. Similarly, across the R also, plus minus. This is the polarity. So, voltage across inductor we consider as VL. So, it will be minus VL and then minus VR equals to 0, which we can also write as VL plus VR equals to 0, because on right hand side it is perfectly 0. Okay. Now, the voltage across inductor VL is defined by L di by dt. We will put this in the equation and we will get L di by dt plus voltage across resistor will follow the Ohm's law. So, it will be R into I equals to 0. Just divide the equation. Divide the equation by L and we will get di by dt plus R by L I equals to 0. Now what we have to do? We have to rearrange the terms and take the I variable on left hand side and t variable on right hand side. So that is called as separation of the variables. So di by dt equals to minus R by Li di upon I. We will take I terms on the left hand side, I variables, and t terms on the right hand side. Next step will be integrate both the sides. But while integrating left side, it will be with respect to I. So, integration 1 of I with respect to I, and on the right hand side, it will be with respect to t. R by L is a constant, so we have taken it common outside. Now, integration. Sorry, this, yeah, 1 upon I is a log I minus R by L, and here it will be t plus k, where k is the constant of integration. First we have to find the value of k. To find value of k, put at t equals to 0 the value of current as capital I0, which we have defined at the starting. So if we will put this initial condition in the equation 1, we will get ln log I0 equals to minus R by L multiplied by 0 because time is 0 plus K. Hence the K will become log of I0 or I0. Now this value of K we have to substitute in equation 1. So let us ln I equals to minus R by LT plus log of I0. Take both the terms of log on the left hand side. And by using the logarithmic algebra, ln I upon I0 is equals to minus R by LT. To find the I equation for I, we will further take the antilog of this equation and it will become I upon I0 equals to e to the power minus R by LT, or we can say I equals to I0 e to the power minus R by L t. Now here for t greater than 0. Now here the tau is equals to L by R. In case of RL circuits, the tau is defined as L by R, which is again the time constant defined for L. Okay. Now substitute this tau in the equation. We can again rewrite this I as I of t, and we can rewrite that I0 because it is L by R. It will become t upon L by R, or we can write I0 e to the power minus t by tau. Condition is t greater than 0. Again we will see that at t equals to 5 tau, at t equals to 5 tau, the value of current becomes e to the power minus 5 and it I0, and it will be approximately I0 times 0.0067 e to the power minus 5, which is approximately 0. It means in 5 tau times the current reaches to its steady state. Just the same response can be plotted. This is a time axis, and here we will plot a current I of t origin. Now at t equals to 0, if we will put in the equation at t equals to 0, you will get a initial value of current, that is I0, and then it will decrease exponentially as we have got the exponential equation, right? It will exponentially decrease, and at t equals to infinite it will reach to somewhere 0, but it will reach to near 0 at, if we will plot it for tau, 2 tau, then 3 tau, 4 tau, so it will reach to approximately 0 value in 5 tau times. So this is the response of source free RL circuit, that is we have derived the equation for current.